We're Group 7 for the Green Engineering Project. We did the effects of geoengineering. The problem is obviously that global warming is a huge issue in today's society. It's led by the gas emissions and the greenhouse gases. Carbon dioxide is the most common greenhouse gas. These greenhouse gases lead to droughts and heat waves, the melting of the polar ice caps, and more hurricanes and earthquakes. It could also lead to economic issues with more expensive fuel because the constant burning of fossil fuels. An overview of geoengineering is that it's a large-scale change in an environmental process that affects the Earth's climate. Some forms of that are ocean fertilization, sun-refracting space shields, artificial trees, and atmospheric sulfate infusion. Triple bottom line for green engineering techniques is economics. It tends to be a bit costly, but scientists believe that it'll pay off in the long run. The social aspect is that it's better living habitat for us, and the environmental aspect is that it lowers greenhouse gases temporarily. First, we're going to talk about sun-refracting space shields. They reduce the greenhouse effect to pre-industrial levels by reducing solar irradiance to a 1.8% level. A shade of 4.7 million kilometers squared would need to be constructed at 0.L1 on this diagram that you see. However, the solar shade would need to be able to increase its surface area by roughly 35,000 kilometers squared to offset CO2 production. The positives of solar shading are potential to reduce melting of polar ice caps and stabilization of the seasons. This would obviously be nice for everybody who likes to enjoy a nice spring and fall. A relatively simple production of lenses, and when no longer needed, could easily be destroyed and without affecting the Earth. The negatives are shading over oceans could reduce photosynthesis of vegetation, which is obviously a really bad thing. Shading or rapid cooling of the Earth cause unforeseen weather phenomena. Another one we looked up was ocean fertilization. Ocean fertilization is a strange process in which iron is dumped into the ocean in order to trap CO2 by creating extra phytoplankton. Phytoplankton are microscopic plants that live near the ocean's surface. Iron dust is dumped into the ocean, and this increases the phytoplankton, which could be a good thing, could be a bad thing, which we'll get to in a little bit. This would be done in areas of the ocean with low activity. The next slide is an overview of the whole process, but you can see where it dropped the iron in, and then you can see where the CO2 cycles into the deep part of the ocean and just gets stored there for a while. So phytoplankton levels would be increased through ocean fertilization. They've decreased 10% since the 70s, so it's not it would technically reboost their population, which could be a good biological incentive to the project. The positive effects of ocean fertilization, like we said, it removes CO2 from the atmosphere, potentially 1 trillion kilograms of CO2 per year. The growth of phytoplankton increases biological activity, and it's a lower cost than other carbon capture methods that are being used right now. The negative effects are the process is relatively untested. It can create dead spots in the ocean due to high phytoplankton activity, which would destroy all the oxygen levels in that part of the ocean, which would be a very bad thing for all biological areas of the ocean, so a lot of people think it's a terrible idea. In conclusion, the negative impacts of geoengineering and ocean fertilization are not worth the positives, in our opinion. The ability to decrease greenhouse gases is something that is much needed, but the unforeseen side effects of metering, solar irradiance, and inability to control the growth of plankton is alarming. Plankton could eliminate valuable oxygen from the ocean and destroy much of the ocean's biodiversity.